Okay, now in this lecture, I want to talk about the physical devices, the hardware that we use in order to convert our decimal into binary coded decimal and the opposite direction, the binary coded decimal into decimal. These are hardwares that we have to use in order to make this conversion happen. So let's focus on the input field device that we need in order to convert decimal to BCD. This particular hardware is called push switches. I'm going to show you push switches here. This is how the push switches looks like. So the operator will just set them at their whatever decimal value required. For example, let's assume that we have a 2 push switch and the operator set the push switch at 63. So it needs to, the set point, for example, needs to be 63. Now, how this 63 will be converted through the push switch? Push switch has 4 switches for each single digit. So in order to show the input module of PLC, it will use 4 input. Here you can see input 4, 5, 6, and 7 are used here in order to tell PLC that we need this particular digit. So for each single digit that PLC needs to read from push switch, in decimal, it needs to have 4 switches, and based on the combination of the condition of these switches, the PLC will know what is the value of your input. So now, in order to see how it works, let's look at the next slide. In this slide, we have the table truth, or we have the truth table for our push switch. So what you can see here is that these are, what you can see here are the 4 switches we need for every single decimal digit. So these are those 4 switches, and they do have different weight. So we have the least significant bit, and here we have the most significant bit. So the weight of each switch is basically different. Now these 4 switches needs to be wired into the terminal of our input module, and then based on the condition of those switches, we can tell PLC input terminal what is the value that we are looking at. If all of them are open, then here you can see that for 0, all of them are open. Then you're going to have a 0. So in order, all should be open in this scenario to get 0. If only the first one is closed, then we are going to have 1. If the second one is closed, we are going to have 2. So this is basically the binary equivalent of that number. So we can show the binary equivalent of the digit by 4 different switches, and those 4 bits needs to be connected to the input terminal of our PLC. Here is another example. In this example, we need to tell our PLC about a set point which needs 4 decimal digits. For example, 9,234. We need to enter this as a data to PLC processor. So this is a decimal number, and if you want to convert this into binary coded decimal, then you need to have 4, which is the number of decimal number, multiplied by 4, which is the number which you need for every single digit, and it means that you need 16 bit for its equivalent binary coded decimal, or in another word, you need to use 16 terminal of your input. So based on how many decimal digit you need to enter, you have to decide how many of your input terminal will be used by wiring to the push switches. And then on the output side, what we have is 7-segment LEDs, and you know how the 7-segment LED works. That's basically in the opposite direction. So the binary value of every single digit will appear at 4 terminal. For example, these 4 terminal are showing the binary value of the output, and then these will be connected to every single digit, and then based on truth table, the 7-segment LED will convert your binary number into a digit, and the digit will be demonstrated.